Aviation has always been about pushing boundaries, but hypersonic flight takes this ambition to an entirely new level. The introduction of hypersonic jets by the United States has the potential to revolutionize travel, shrinking the world like never before. With speeds far exceeding anything we have today, hypersonic flight promises an unprecedented leap in air travel efficiency. However, this innovation doesn't come without challenges. From groundbreaking technological advancements to the players driving this bold vision, let's explore the future of hypersonic aviation. The concept of hypersonic flight and its challenges. Hypersonic flight refers to traveling at speeds greater than Mach 5, which is over 5 times the speed of sound. While this opens up extraordinary possibilities, such as reducing transatlantic travel times to under an hour, achieving such speeds presents significant challenges in physics and engineering. One of the biggest hurdles is the immense heat generated at hypersonic speeds. When an aircraft reaches Mach 5, the air molecules around it collide with such intensity that temperatures soar above 1,800 degrees Fahrenheit. This heat can melt ordinary materials, necessitating the development of advanced heat-resistant materials and cooling mechanisms. Engineers are also tasked with addressing aerodynamic drag, which increases exponentially with speed and demands energy-efficient propulsion systems. Unlike supersonic aircraft such as the Concorde, which relied on turbojet engines, hypersonic aircraft require entirely different propulsion technologies. Turbojet engines are inefficient at these speeds, and advanced systems like ramjets and scramjets must take their place. However, these engines face their own challenges. For instance, ramjets and scramjets can only operate at supersonic speeds, making takeoffs and landings highly complex engineering feats. Additionally, maintaining stability and control at hypersonic speeds requires innovative solutions to counteract irregular airflow and turbulence. The technologies enabling hypersonic flight. The transition from hypersonic flight as a concept to a practical reality relies on several cutting-edge technologies. Among these is the turbine-based combined cycle engine, such as the Chimera engine developed by Hermes. This hybrid engine integrates turbojets, ramjets, and scramjets, allowing for seamless transitions between low-speed and high-speed flight. By combining the strengths of each propulsion system, the Chimera engine minimizes the drawbacks that come with relying on a single engine type. Advanced materials also play a critical role in enabling hypersonic flight. New alloys, ceramics, and composites are being developed to withstand extreme thermal and mechanical stresses. Some designs incorporate internal cooling channels to dissipate heat effectively, preventing structural failure. Navigation and control systems are equally vital. At hypersonic speeds, even the slightest inaccuracies or delays in data processing can lead to catastrophic consequences. Artificial intelligence, machine learning, and sophisticated sensors enable real-time decision-making, ensuring stability and control. Moreover, companies like Hermes are adopting cost-effective approaches by using readily available parts for testing and development, accelerating the timeline for innovation. Hermes and the Quarter Horse Program. Hermes, a leading player in hypersonic aviation, is at the forefront of this technological revolution with its Quarter Horse Program. This initiative is focused on testing and refining hypersonic capabilities through a series of advanced prototypes, including the Mk0, Mk1, Mk2, and Mk3. The Mk0 serves as a ground-based testing platform, evaluating essential systems and functionalities. Remarkably, it was constructed in just 6 months and successfully met performance standards, including state monitoring and loss link testing. Building on this success, the Mk1 is set to undergo test flights by the end of 2024, demonstrating high-speed takeoff and landing capabilities. The Mk2 prototype features the upgraded Chimera 2 engine, capable of reaching speeds up to Mach 2.5. This model will also test the transition between turbojet and ramjet propulsion. The ultimate goal is the Mk3, which aims to surpass the SR-71 Blackbird's airspeed record by achieving Mach 4. Each iteration of the Quarter Horse program brings the dream of hypersonic flight closer to reality, showcasing the rapid pace of development and the potential for scaling such technologies. Hypersonic flight beyond defense, commercial applications. While hypersonic technology has traditionally been associated with defense and research, its potential for commercial aviation is increasingly being explored. Companies like Hermes envision passenger aircraft capable of drastically reducing travel time, such as completing a New York to London flight in under 90 minutes. These aircraft would operate at altitudes of over 100,000 feet, where reduced air resistance and drag result in lower fuel consumption. However, several obstacles must be overcome before hypersonic flight becomes a commercial reality. Sonic booms, loud noises generated by hypersonic aircraft, can disturb populated areas. To address this, researchers are designing quieter aircraft and planning flight paths over sparsely populated regions or oceans. Environmental concerns also need to be mitigated, as hypersonic engines have higher emission rates per mile traveled. The development of sustainable fuels and advanced engine technologies offers hope for minimizing the environmental impact. Cost remains another significant challenge. The advanced materials and technologies required for hypersonic aircraft make them expensive to produce and maintain. However, lessons learned from prototypes like the quarter horse could help reduce production costs over time. Additionally, regulatory frameworks must be updated to accommodate the unique challenges of hypersonic flight, including international treaties, safety requirements, and noise regulations. The evolution of hypersonic flight technology. The pursuit of hypersonic flight has its roots in military research, particularly during the Cold War, when global superpowers invested heavily in high-speed reconnaissance and defense systems. Notable milestones include the SR-71 Blackbird, capable of reaching Mach 3.3, and NASA's X-15 program, which achieved speeds of up to Mach 6.7 in the 1960s. These early efforts provided valuable insights into the challenges of heat management and propulsion at extreme speeds. The 1980s saw the introduction of the National Aerospace Plane Program, which aimed to develop a single-stage-to-orbit vehicle. Although technical and budgetary issues ultimately halted the program, it contributed significantly to advancements in material science and propulsion technologies. In the early 2000s, scramjet-powered aircraft like the Boeing X-43 and X-51 demonstrated the feasibility of air-breathing propulsion at hypersonic speeds. The X-43 reached Mach 9.6, while the X-51 achieved Mach 5.1 during a 4-minute flight. These projects laid the groundwork for modern hypersonic designs, despite challenges such as combustion instability and the need for auxiliary propulsion during takeoff. The role of private companies in hypersonic development. Private companies are increasingly taking the lead in hypersonic technology development, as demonstrated by Hermes and its groundbreaking quarter-horse program. Unlike traditional government-led initiatives, these private enterprises are showcasing their ability to innovate quickly and cost-effectively. By adopting a modular approach and leveraging existing technologies, Hermes has significantly reduced development timelines and costs, proving that private firms can compete in areas previously dominated by state-funded programs. This approach also fosters a culture of rapid prototyping and iteration, allowing companies to address challenges and refine designs in record time. The quarter-horse program's success highlights the potential for the private sector to drive innovation in this field and redefine the boundaries of aviation technology. Each new prototype brings hypersonic flight closer to becoming a practical reality, with significant implications for both defense and commercial aviation. The Mk3, for instance, not only aims to break existing speed records, but also serves as a critical testing platform for integrating advanced materials and propulsion systems. Meanwhile, the Chimera engine represents a major breakthrough in propulsion technology, enabling seamless transitions between low-speed and hypersonic travel, a feat once considered unattainable. As private companies like Hermes continue to refine their designs and push technological limits, the dream of routine hypersonic travel becomes more attainable. Their efforts not only pave the way for transformative changes in global transportation, but also inspire a new era of innovation in aerospace engineering, setting the stage for collaborations that could further accelerate progress in this exciting domain. Thanks for watching. If you thought this was fast, just wait until hypersonic travel turns your 12-hour flight into a blink, and you miss it. Now, good luck finishing your in-flight movie. Don't forget to like, share, and subscribe, or else you'll be stuck traveling at regular speeds forever. Hit that bell icon so you can stay ahead of the jet stream. See you at Mach 5.